In this video I'm going to be looking at the solution to question 8 of the June 2010 Edexcel M1 paper. The topic of the question is connected particles and kinematics. The question starts by describing the diagram figure 3, which is about two particles A and B of masses 0.4 and 0.3 kilograms attached by a light inextensible string over a smooth pulley. We're told that the particles are initially held 1 meter above the floor and then released. In the first part of the question, we're asked to find the tension in the string immediately after the particles are released, and then to find the acceleration when they're released. Once we've done that, the question goes on to say that after half a second the string breaks, so that B will then fall back towards the floor, and we're asked to find the further time that elapses until that happens. Well, the first two parts of the question are a fairly standard question about connected particles over a pulley. So that I've drawn the information onto the diagram already, where we've got the weight 0.4 G and 0.3 G acting downwards, and the tensions which are transmitted through the cable T acting upwards. So using F equals ma for each of the particles in turn, taking A first of all and using positive direction as being downwards because that's the way it's going to accelerate, we get that 0.4 G minus T is equal to the mass 0.4 multiplied by the acceleration A. In a similar fashion, by this time taking the positive direction as being upwards, T minus 0.3 G is 0.3 A. If I call these equations 1 and 2, the first part of the question requires that we eliminate A, the acceleration, from these two equations. So taking 4 times the second equation and subtracting from that 3 times the first equation, then that gives a total of 7t, so 4t minus negative 3t, 7t, minus 1.2 g, and again from the first equation minus 1.2, so in total minus 2.4 g. And on the right hand side, of course, 0, because we've arranged those multiples to eliminate a. That then gives t is equal to 2.4 g divided by 7, which is 3.36 newtons. To find the acceleration, well, instead of subtracting this time, if we add the two equations, that's going to eliminate t, so that adding those gives 0.1 g is equal to 0.7 a, and therefore the acceleration is 0.1 g divided by 0.7, which turns out to be 1.4 meters per second squared. The marking for these two parts of the question was to give an M and an A mark, method and accuracy mark, for each of these two equations. And then, dependent on getting that correct, so what's called a DM mark, dependent on that method, you get another method mark for eliminating A, and finally an A mark for getting the correct value for T. In part B of the question, there's another DM1 mark, dependent on those two equations again at the top, and then an A mark. So 6 marks for the part A and 2 marks for part B. It would be possible to answer this by working out the acceleration first, because it's probably an easier calculation to do, and then using substitution to evaluate T. The marks would be allocated in an equivalent way. In part C of the question, we're told that after half a second, so t equals 0.5 seconds, the string breaks. So at that point, B is going to be up in the air, having moved some distance that we can calculate, and will be moving upwards, so with some velocity v that we can also calculate. So to do that, we need to use kinematic equations of motion, starting from the initial position here and saying, well, at that point the initial speed was equal to 0. The acceleration we'd calculated in the first part of the question was 1.4, and therefore using v equals u plus at, the velocity v that I've indicated on the diagram would be 0 plus 1.4 times 0.5, which is 0.7 meters per second. So we know now that it's moving upwards with a speed of 0.7 meters per second. To calculate the height, we can use s is equal to ut plus 1/2 at squared. So this is 0 plus 1/2 multiplied by 1.4 multiplied by 1/2 squared, and that gives you 0.175 meters. So the total height above the ground is therefore 1.175 meters. So just putting that onto a new diagram then, we're starting off with B at a height of 1.175 meters above the ground, moving with what is now going to be an initial velocity of 0.7 meters per second, the velocity that we've just calculated. We want to find the time that it takes to reach the ground. So in other words, using s equals ut plus 1/2 at squared, we know that the final value for s will be negative 1.175. The initial upward speed is 0.7, and then the acceleration is downwards, so negative 1/2 multiplied by acceleration due to gravity, which is 9.8, multiplied by t squared. This gives a quadratic, which is 4.9 t squared, that's from the last term on the right hand side, minus 0.7 t, and minus 1.175 is equal to 0. The value of t then can be found by using a quadratic formula. So t is minus b plus or minus the square root of b squared, all divided by b squared minus 4ac, all divided by 2a. So that t is equal to minus b, which is 0.7, plus or minus square root of b squared, so 0.7 squared, or negative 0.7 squared if you wish, minus 4 multiplied by 4.9 multiplied by c, which is negative 1.175, and everything then divided by 2 lots of a, so everything divided by 2 multiplied by 4.9, and that evaluates, well, we want the positive value, obviously, not the negative value, so that evaluates to be 0.566 to 3 significant figures. So that's 0.566 seconds to 3 sig fig. So that's the extra time until it hits the ground. Well, quite an involved part of the question there. So 9 marks in total, which are allocated as follows. There's a method mark and an accuracy mark for getting the value 0.7, and also method and a mark for the 0.175 meters there. Then using that, once you've got that, then a dependent method. So if you don't get those correct, then I'm afraid that the rest of the question is not going to score any marks. So, sorry, dependent on the method this is. So that there is a DM mark for using the S equals UT plus a half a D squared correctly, with an A mark, and then finally solving that DM1 and A1 here with an answer mark at the end. So in total 9 marks there. Now some of these are follow through marks, so these were follow through on the first part of the question, and then also following through a mark there. The final ones, however, was a correct answer only. Well, that concludes that question. If you want to see videos for other questions, then you can find them at www.furthermaths.org.uk.